Hi, this is Daryl Lewis-Sandy from Maana. Welcome to the 6th training video in our series about the physical quantity service. The physical quantity service is a GraphQL-based microservice that provides the capability to parse and extract physical quantity mentions from strings, to convert between units of measure, and to perform arithmetic with physical quantities in a way that respects their physical dimensions. In today's lesson, we'll be learning how to persist structures from the physical quantity service, which will give us the ability to create our own domain-specific systems of units with custom units of measure. This video series uses a workspace services template that contains all of the exercises that we'll be working through in these tutorials. If you've been following along with us on our previous videos, you already have your own copy of this workspace, and you should open it now. If you've just joined us, you should take a moment to clone your own copy of the Maana Physical Quantity Tutorials template. This template can be found in the Services tab of the Maana Q Intelligence Designer portal. In today's lesson, we'll be learning how to persist physical quantity structures to Maana's KindDB. We'll be using this new knowledge to create our own unit of measure and our own system of units. We'll then be creating a function called parse and save that we can use to parse physical quantities from strings, including our new units of measure, and store them to KindDB. As with our previous lessons, there's already a knowledge graph created for this exercise, and it's labeled Lesson 5, Saving Quantities. Inside this knowledge graph are all the kinds and functions that we're likely to encounter in today's exercise, including the function that we're creating, the parse function, which we've used several times now, the add system of units function, which is the standard CRUD operator for saving systems of units to KindDB, then two new functions, persist physical quantity and persist simple unit of measure. At first glance, these persister functions may look just like the built-in CRUD operators, but there are some important differences. Let's take a moment to look at them in more detail. The physical quantity service provides two different ways of storing its kinds to KindDB: the built-in CRUD operations and these persister functions. To illustrate the difference, I've placed both of them here on the canvas. As you can see, the persist function takes an instance of the physical quantity kind, which is a highly structured object. When we run the persist physical quantity function, it recurses through the structure of the instance that we provided it with and saves every instance of every kind that it encounters, including the unit of measure, all of its factors, the simple units, the prefix, the unit of measure conversion, and the physical dimension. This is useful when we're saving a physical quantity that may contain units of measure or physical dimensions that are the result of a calculation, and we may not have encountered them before. This ensures that they're stored at the same time that the physical quantity is, and that they're available for us to retrieve when we retrieve the physical quantity. The built-in CRUD operation, add physical quantity, takes as an argument an instance of the add physical quantity input kind. This kind is very simple compared to the physical quantity kind, and contains an ID of the unit of measure rather than the whole unit of measure structure. The built-in CRUD operator is best used when you're certain that the unit of measure associated with any physical quantity that you're storing is already stored in KindDB. So to demonstrate the use of the persister, I'm going to create a new unit of measure called G, which is an acceleration, a unit of measure of acceleration, that at the same time that I create a physical quantity that uses it. So I'm going to open up the run dialog here for the persister, and let's say we've just measured 3 G's. Now G, the standard notation is GEE, and we've got a magnitude of 3. Now we have to define the unit of measure, and the customary symbol for the unit of measure is G, so we'll put that there. Has one factor, and that factor has no prefix. It has an exponent of 1, and a base unit of measure, which is 1g. Physical dimension is an acceleration. If we look here, there it is. We'll pick it from the drop down. And we have to give it an SI unit conversion. So I happen to know that 1g is 9.8 meters per second squared, which is the standard SI unit for acceleration, meters per second squared, and no offset. So the offset you really would only use when you have a temperature or perhaps a gauge pressure where the 0 on that scale is different than the 0 on the SI scale. If we clear the cache and run this, we can see that it has added our new physical quantity, 3g, and we can in fact confirm that by looking at the data view. Look all the way at the bottom there, and we can see 3g. And moreover, if we look here in the simple unit of measure, we can see that it's created a new simple unit of measure called g with the dimension of acceleration and using our unit conversion. So that's excellent. Now, whenever we measure an acceleration in g's, we can use that unit of measure. So to demonstrate that, I'm going to add another physical quantity here using the CRUD operator. We'll enter a measurement of 15 g's and a magnitude of 15. And here we don't have to provide the whole structure. We only have to provide the ID of the unit that we've already defined. And we can run that. And very quickly it's returned 15 g's, the ID. If we look in physical quantity, we can see that there is our new entry, 15g. You should now have all the information you need to work through today's exercise. Remember, you're going to be creating a function called parse and save that parses a physical quantity and then saves it to kind2b. If you'd like a little bit of an extra challenge, go ahead and create your own unit of measure and your own system of units that includes that unit of measure, and try using that with your parse function. I'll be back in a moment after you've had a chance to try your hand at this exercise. Welcome back. I hope you all had a chance to work through this exercise and come to a solution on your own. Let me walk you through mine. So I know I'm going to be creating an implementation for the parse and save function, so I'm going to open up the function graph for that function. I also know that I'm going to need some of the functions that are on the canvas in this implementation. So I'm going to bring those in right now. Bring in the parse function and the persist physical quantity function. Now, looking at the types that I have available here, it looks like the source, which is the string we're parsing, should go into the string input of the parse function. And the system of units IDs should go into the same argument on the parse function. And the physical dimension name also should go into the physical dimension name of the parse function. As you recall, these optional arguments, the system of units arguments and the physical dimension name arguments, allow us to restrict the physical quantities that are returned by the parse function to those that occur in the system of units and have the physical dimension that are provided. Now, the last thing that I need to do here is save the physical quantities that were parsed into kind2b. And because those units of measure might include ratios or products of units that I have not previously saved in kind2b, I'm going to go ahead and use the persist physical quantity function to save all of the structure all at the same time. Right, now I've connected that together, and we can go ahead and run that. To test our function, I'm going to parse and save a very simple physical quantity. I'm not going to tell it a system of units to use, and I'm not going to tell it a physical dimension to restrict this to, so it will use all of the units in the 3 default unit systems, the oil and gas domain-specific units, the MKS SI system of units, and the imperial system of units. When I run that, after a moment we could see that it saved 15 meters. It's returned to us the ID of the physical quantity that it saved. So that works. So what if we want to use our own unit of measure? Let's go ahead and create a new simple unit of measure using the persister for simple unit of measure. So I'm going to create a unit of measure using my name. And I'm going to make this a dimension of, why not, area. And then I need to give a conversion to the SI unit. And I'll give it a multiplier of some random gibberish with an offset of 0. And after a moment, we can see that it created a simple unit of measure called Daryl. So I can use this anytime that I would want to create an expression of ratios or products of simple units to build up a unit of measure expression. But there's one more step that I need to do here if I want to use my own custom units of measure with the parse functions. And that is, I need to create a custom system of units that has all the units and prefixes and aliases that I want to be in scope when I call the parsing function. So to create a new system of units, I'm going to use the built-in CRUD operator. And the reason that I'm using the boilerplate CRUD operation here rather than a persister is that I've already saved the units of measure that I want to include in this system of units. So I don't need to traverse down through the entire system of unit structure. I can create the new system of units merely by referring to the units of measure that I've already created. So here we go. I'm going to create a new system of units using my name, Daryl system of units. I'm going to use my G unit of measure that I created earlier, but I'm also going to pass in the new unit, the Daryl, that I've just created. Even though I don't have any prefixes that I want to use, I still have to give it an empty list of them, and I also have to give it an empty list of aliases. So now that I've populated that, I can run it, and after a moment it comes back with the ID of my new system of units, and I can use that in parsing units of measure. So to test this, I am going to parse and save 3.5 kilogram G per Daryl, which should be a pressure. And now you'll notice that this uses units from the MKS system as well as my custom system of units. So I have to provide the IDs for both of those systems of units. And I want to make sure that this only parses if it is in fact a pressure. When we run, after a moment, we can see it's returned the ID of the physical quantity that it stored, 3.5 GkG per Daryl. So it's that easy to create your own custom units of measure and your own system of units and use them to parse domain-specific units of measure. In this way, the physical quantity service is extensible and can grow to meet your particular needs. Well, that wraps it up for today's lesson. I hope that you enjoyed learning about persistence of physical quantities and how to create your own units of measure. In our next lesson, we'll be learning about comparison functions, which allow us to tell whether one physical quantity is larger than another, and let us find the maximum and minimum of a collection of physical quantities. I hope to see you then. If you enjoyed this video and want to learn more about the physical quantity service, don't forget to subscribe to the Maana Inc. YouTube channel